Here's another very stupid question that I saw, and it was actually stumping a lot of people. So it was baffling a bunch of folks. So what I want to do is this, right? Given you're given a tree, a binary tree, okay? You're given a binary tree. It's not a full-formed binary tree. It's not a binary. It's a regular binary tree, but it's like branches all over. There could be missing branches and whatnot. So let me draw the binary tree first. Okay. So you've got a 1 here. You've got a 2, 3, 4, 5, 6, 7, 8, right? This is what you have, okay? Now, what I want to do is I want you to actually show me what would be the view of this binary tree when, like, the left projection of this tree. Okay? Left projection of this tree. So if I look at this tree from here, what do I see? I see 1. I see the 2. I don't see the 3. Because 2 is hiding the 3. I see the 4, I don't see the 5 and 7. I see the 6, I don't see the 8. Okay? How do you do this?
Level order traversal and take only first element.
So you do the level order traversal and take the first one.
Yes.
How much time did it take for people to get to this? Like, it was quick, right?
Yes.
So this question, it's a stupid question. It's very easy, simple. If you know what you're trying to do, how? What about right view?
Take the last element. Or else put the right child first. Take the first element again.
So how do you do leave the first problem? How do you do the last element?
So you iterate the level order. No. We will keep putting all the node to queue, all children. In the iterate through the queue whole last element whatever you are getting, you will take it. It may be more expensive, but still it will work.
Why don't you reverse it?
Yeah,
that's what he said. We do the other one, right? So basically, put the right side first and you're done, right? So that's a classic case. Okay. What about top view?
Top view. It's
Left view, right view is easy. Top view. So what does the top view look like for this?
1, 2,
1 is here, 2 is here, 2 to the left,
3
to the right,
4
4 to the thing,
7.
5 is hidden by 1.
Yeah.
7 is there. Okay. 8 is hidden by
3.
6 is hidden by 2. Okay. This is the view.
This one also I already solved, so I don't want to.
Okay. Good. I didn't know if you're good. Actually, I saw this question somewhere and it was like, it's interesting. So this is the top view, right?
Basically, you keep a point when you inject. You also keep give the index. Like 1 goes with index 0, 2 goes with index -1, 4 goes with index -2, and whichever is the index first.
Have you solved the question of column sum? Find the column sum of a tree, right?
Yes.
How do you do that? What data structure would you use?
What is column sum?
Column sum is sum the columns. So 1 will be added with 5, will be added with 8. No, not 8. 1 and 5 will be added.
Yeah.
3 and 8 will be added. 7 will be added separately. 2 and 6 will be added. So every time you go left, it's -1. Every time you go right, it's a +1 column. Okay? Anything that's the same column, you just add it up. So finally, at the end of the day, it's essentially same thing, but it will essentially be 1 plus 5, 3 plus 8, and 2 plus 6. Okay? It's the same problem, except that in column sum, what you do is that you keep adding.
Yes.
In this one, if the data already exists, then don't add.
Don't add.
Yeah. So basically, you keep an array of
It's a dictionary.
height.
Or hash.
Array of height.
Why? Height.
Because you can go up to the width of the tree, right? You can go up to -2 here and 2 on the other side.
No, you don't know the height. Height is not an intrinsic property of the tree. You have to calculate it anyways.
Hash table there. Dictionary. Sorry.
Go ahead.
I'm not sure if this is correct or not.
That's okay.
I'm thinking about like,
Hang on, Supriya.
if you go left, then you only take your left extremes, and if you go right, you only take the right extremes.
That's not true because I could have 6, 2, 1.
Or even the 8 can comes
No,
all
what?
the way.
Or the 8 can also go all the way
Yeah.
here left, right?
Yeah.
So-
That's right.
Good point. But no, that may not work.
I mean, one way is that we start with the 1.
Mm-hmm.
Then we basically keep the range that I have already taken care. So 1
Can
is
you
say
think of
0.
a data structure?
Huh?
Can you think of a data structure that actually can grow on both sides?
Both sides. It's
And can actually go, I can go left or right in any way.
A dictionary
anytime.
can grow on both sides, given that you keep a min and the max.
For dictionary, it's a key value.
Yeah,
Yeah,
key value.
exactly.
Exactly.
So a dictionary will work. There's nothing wrong with the dictionary
Yeah.
because dictionary is just
Provided
your,
you keep a key and value here because you know contiguous.
correct. But let me ask if there's a
double-ended queue
not Q.
Then
List.
linked
List.
list.
Select
List.
a doubly linked list.
Yeah, doubly linked list.
Would be the classic data structure for this,
Mhm.
where what you do is that you insert 1, okay,
Yeah.
at column 0. Okay? Then when you go left, you insert 2 at column -1.
Yeah.
And then you insert 4 at column -2. Okay? Then you come back when it comes to 2, right of 2 is this, right? So you want to insert 5 at column 0. So depending on what problem it is, if it's a column sum problem, then you add this. If it's the top view of the tree, then you don't do anything. If it's a bottom view of the tree, what do you do?
We go to replace.
You just replace it.
Yeah.
That's it. I mean, at the end of the day, it's the same problem in
Exactly.
so many different forms. It's nothing fancy.
Yeah.
Okay. So depending on what type of the question it is, it's just that. So the question, the way I phrase it, is essentially saying find the left sum
Yeah.
and the left view. Left view is pretty simple.
Yeah, so
Okay. Find the right view.
That's also
Easy. No, nothing else. Find the top view. Top view is essentially if you have solved the column sum problem, then you should know how to do it. If not, you can use it. Doubly linked list is the ideal data structure for this. You can always use a map or a dictionary to do that. That also works. Because essentially in dictionary, you're putting key and value.
Yes.
Since it's contiguous, doubly linked list works best. Okay? And then essentially if I say bottom view, then it's the same approach. You do that.
Perimeter.
Uh-huh.
Perimeter is another one.
Sure. The perimeter is the
So doubly linked list, we are managing this 0 -1 that value also.
you don't need to.
That part actually I'm not able to.
You don't need to.
Yeah, when it is coming back to 5,
Uh-huh.
in case if I want to display a bottom view, how can you find the value 1 and replace?
You have the pointer, right? Pointer.
You know where you are, right? So essentially when I'm here,
Yes.
I know that I am going to point to this point of doubly linked list.
Yes.
When I'm actually going to this 2, I'm going to hand the left
Yes.
If it is a
list
null,
dot left.
if it is a null,
If it's null, then I'm going to create a new list dot null and then give it to you.
okay.
So that way you know where to put your 2. Once you put the 2, then I will go to 2's right, which is exactly where 1 was, and then I'm going to try to put 5. If it's already null, then I'll create 1 and go. That's it. It's very so you don't need to know the column number for this.
Okay.
And once you're done with everything, finally at the end of it, you go all the way to the back and then you say, here's where I am.
Okay, so 1, 2, 4 we put, and then 5.
You put 4, right?
Yeah.
Where are you
at
gonna put
this
5?
point I am clear. 5, where you are going to?
5 will put it here. 5 will be here because that's actually to the right of 2, right? You know that. 2, what did 2 get? 2 got a pointer to the left of 1.
So you
2
will be
got this
iterating-
pointer.
So you will be iterating the end of the left first, then you will
No,
come
why?
back.
Recursive, no?
Why?
Okay.
It's a DFS, right? So so essentially this will have a pointer to 0.
Yes.
When it goes here, this will be a pointer to 1, this will be a pointer to 2, minus 1, this will be a pointer to plus 1.
1. Yes.
Okay? When I'm going here, this will be a pointer to the node at -2.
2.
This will be a pointer to node at 0.
0. Oh, sorry. Yes.
And then this will be a node to point at -1.
1. Minus
This will be -2 and so on.
Yes.
Yeah, this can be easily changed to see the bottom view. Also.
Bottom view is like is replace.
Always keep replacing.
Always keep replacing is bottom view. Never replace is top view.
Yeah.
Keep adding is the columns.
Columns.
Same problem in 3 different aspects of it. It's not a
Mm.
so anyway, stupid question, but fun.
Yeah.
Interesting, easy question. This is like a minute code exercise of sorts.
Perimeter.
Explain perimeter. What is perimeter?
Like just the outer columns, not the inner columns.
Uh-huh.
For example, here the answer would be 1, 2, 6.
So assuming these are not there, right?
1, 2, 4. Yeah, it can.
1, 2, 4, 6,
8, 7,
7, 3.
1.
Okay. So what if there is something else here?
Then 6 and 2 both.
Oh,
6 and 2.
6 and 2.
Why 6?
6 is also the outer space.
How-
it's
So if
like-
something has 2 children, it is not considered outer.
No, something which is hidden.
How is
Five
it?
is
Why
hidden.
is it? Why is it? How is 5 hidden?
5 is
How is
hidden
5
between
hidden?
4 and 7.
For this 6
How is
will
5
not be
hidden?
in answer.
If you see
Vertically is
that-
hidden by 4 and 7, but horizontally it's not hidden, right?
So if you
Vertically
see
it's not hidden.
if you see it by level, you just take the 2 outer side. So if you go
Yeah.
level by level, you
Yes.
just take the 2 outer
2
side.
outside,
basically.
exactly.
Okay. And so vertical hiding is not required.
No.
So basically 1, 2,
Okay, so
4,
this
Because
is
it's a
not
parameter,
hidden.
so you have to see all the
So
sides.
take this, take this, take this, take this, take this,
Yeah.
take this, and take this.
Take
That's
that.
what I say. And then you do it in the diameter of the tree or like the perimeter of the tree. And at the
Basically
Basically,
5 also gets in.
why?
5 gets in because 5 is also exposed to from the bottom.
From the bottom, so that's what I was thinking. So if 5 is exposed from the bottom, then that's also in.
Let's say if you have 3's left child, that will not get it.
Sure. If 3 had like a,
Why?
that will not get it.
5 gets
Why?
into.
It will still go in, right? If you write a perimeter.
No, this is hidden, right? It's the same column.
Oh, okay, so 5 also gets in.
Actually, 5 or 4,
No,
any one
it's
of
not
them
the
can
same
get it.
column.
Depending on which one you take it. Yeah,
Which one you take it,
Either 5 hides 4 or 4 hides 5.
Fine.
You don't know which one.
one of them will get
But I'm
it.
assuming 5 hides 4 because you're going
Why did
anti-clockwise.
hides
You're going clockwise. You're going only on the other. You got to pick away, and then. So this perimeter thing always bothered me because from a graphical representation it's very hard for me to figure out. I've had this people ask this question.
But actually, the simpler way to explain that is like for every level, you have to find the ends
First
of the
end.
level.
That's okay. For every column,
Sure.
you have to find
The other end.
No,
So
but
the
then
thing-
I think there are two answers that doesn't make sense because if we do this way, we get 4. If we do this way, 5. Though, I think there is something missing because it's
Yeah.
No,
centralized.
and, actually for the bottom view also that will be a problem.
Yeah.
Even for the bottom view, right?
Which
You
one?
don't know whether you which one you process first,
Yeah.
right? If I process from right to left, by 5 will be written first and then 4 will be overwritten. Like top view is not is unambiguous.
Yes.
Bottom view is ambiguous because I just realized that as we talked.
But why am I putting them in the same column? That's what I don't. They're like two. I thought they come in their own individual columns.
So the columns are actually the.
If you make a balance binary, that will help solve some of the.
So let's
conditions.
put a very simple balance binary, right? So let's do
They
one.
create their own columns. So they
Whereas
will not have
one is in column simple column, 2 is in a column here, 3 is in this column, okay?
Yeah.
4 is in this column, 7 is in this column. Where is 5 and 6?
I thought it comes in its own
Come
column.
from 2.
No, not one column. So 5 will come in the same column as this, and 6 will also come in 4. Sorry, 5 and 6.
Yeah,
Okay.
5 and 6.
They are in the same column.
Why-
1, 3,
why
and
they
1,
are-
5 and 6 are the same column.
Why on the same column? I mean, when the tree is bending, they will locate a different column, right?
Every time you go left, so according to the rule that we just talked about, every time you go left, you are going one column to the left. So this is column 0, this is column -1, this is column
0.
Plus
0.
Oh, 0. Yeah.
This is also column 0, this is column plus
Plus
1,
one minus-
column 2, column -2, right? So these are all column zeros. In the vertical sum problem, you add 1, 5 and 6. In the top view problem, 1 hides 5 and 6.
But
In the bottom view problem, I have a problem because it's unambiguous.
Yeah.
It is not unambiguous, it's actually there are some challenges there. Good call.
They're like 4, if 4 have children and 5 have children, they are.
If
for
4
the-
has a child of 7 and 5 has a child of like 2,
So they will have
same
the
column.
same issue.
column is -1. Because anything to the right of 4 is actually one column more than 4. Anything to the left of 5 is one column more than 5. Right? Okay?